Hello everyone, this is a quick overview of my custom game project called EchoPad. I built it using C++ for my EECS-498 game architecture file, and it includes a few core features, plus a custom game controller support system, supporting the Xbox and PlayStation. Uh, so I will give you a quick overview first. EchoPad is a lightweight 2D game engine. It's designed to be a modular and easy to build on. Everything runs through an entirely component system. So instead of using a one giant object with all of the logic, each game object is made up of small and reusable components, like its position and physics system. Um, yeah, and so I will go go through my engine first. Firstly, it's my engine. Engine is how I read the files. I put every game file under the resources. I can show you at here. Everything is under the resources, so you can find your actor templates, your components, your fronts, your images, and the render logic, render details, scene details. Yeah, and for under this engine is called scene. Scene is something you can see for each level of your game. If you play a roguelike game before, you will know that for roguelike game, you will make different enemies and different objects for every level. Every level you into, it's everything will change. So that's how engine scene works. Um, to make sure you can see the different thing in different levels. And under the thing, we have actors. Actors is where you store your enemy information, controlled actors information, and NPC information. So how they works, how they move, what dialogue they will say, something, everything like that. And under the actor, we have component. Components is what I talked about before. It's just how the game works, the game logic. And beside the components, we have the render. I use SDL2 for rendering parts, like rendering the front, rendering the image, rendering the audio and text. Everything you want is working right here. And I use JLM for mass calculation to calculate what position should I render at, and what the distance between two objects, and how they collide with each other. Something logic like that. I use JLM. And for rigid body is a physics control in my project. It's control the collider and how the gravity and how the physics. And I use Box 2D in this part. Box 2D is a engine, is a like feature that Angular Bird used. And yeah, and the most important is input. That's where I added my custom features. It's called controller support. I followed the same idea I did before for my keyboard control. For controllers, I also create a couple other map to store the controller states, to store the information when you press the button, when you release the button, and when you move your joysticks. And yeah, same thing as keyboard. I store also transfer the each string to STL readable variables for button and the sticks. Okay, and I will go through how it works in detail. And firstly, in my init function, I called the STL init subsystem. This is how I init the whole controllers. The every controller connected, and then I will go through this loop for loop to check how many controllers we have right now, and if this controller if this connected devices is a controller, and we will add it to the controllers map. Yeah, and in my process event is the logic how it works. we can record it if the controller is still connected or not. We can record if the button is pressed or if the button is removed and is released, or is if the joystick is moved, everything like that in here. And also I added some helper functions called get button, or same idea as I did in get key. And also one funny thing I added called vibration. If you played if you use the controllers before, you will notice sometimes it will vibrate to when you call something, when you trigger with some dialogue. Yeah, so I added that features in my engine, so you can call that, yeah, to make sure it can work as the the market game. It's the same thing as the market game. Yeah, and then I will show you how it works in Lua and how I added those components. So under my resources, I have component types, and in my component tab, I have keyboard controls. I put controllers support and keyboard in under the same file. So right here, you can see we have a code written by Lua in my onUpdate function. Under my onUpdate function is called on is controller connected. If it's controller connected, we can use controllers. We can moving controllers and get some reactions. If we get a button D-pad right or D-pad left, where it's moving the joystick, it will move. And if we press the button, like A or B, it will jump. Yeah, so this is how I added my controller support within Lua, and how to write Lua code to let my C++ know how to, and then render the correct thing as a real time. And yeah, and then I will show you a video that I played to show you guys how the game controller real works. Hello, in this video I will show you guys how my engine supports controllers. Let's run the game. Run succeeded. If we move the joystick to right, it will go right. Move to the left, it will go left. If we press the A button, it will jump. If press same as B button, it also jump. So we can control the ball with the button. Yeah, this is how it works. Perfect. Okay, thank you for watching.